Welcome. We're going to look all about parallelograms today. So the first thing that we're going to do is we're going to build a parallelogram. This we did the first couple chapters where, actually chapter 1, where we took some triangles and then we rotated them and reflected them and did all sorts of things. So, with this one here, if I ask you to rotate this 180 degrees around the midpoint of one of the sides, you have lots of options. We can go around here to get this little shape here. Of course, you can go around here. You're just going to be kind of in your space there. And then, of course, you can go around here. Each one of these guys produces something special. So if I do this, I'm going to go ahead and just mark it right here and then go ahead and draw it. So I have, here we go. I can have it on my paper. So I've got my shape there, and then I have this marking and this marking and this marking. So this shape is definitely a quadrilateral. To be as specific as we can, we would need to look at some evidence. And so I see that these two guys are equal to each other, and alternate interior angles that are interior angles that are congruent to each other give us parallel lines. So these guys here make these parallel, and then these guys here make these parallel. So let me show you that again with a highlighter here. The two yellow ones make the yellow guys parallel to each other. So that means that this shape is a parallelogram. If this is truly a parallelogram, then what information do you now know about the sides? So the sides would be that these opposite sides are equal to each other and these opposite sides are equal to each other. And the angles, I now know that these opposite angles in a parallelogram are equal to each other in this case. And I also know that this combo and this combo are equal to each other. So we're going to prove that all of that information is really true. Now, here is the kicker. For this one here, I started with a triangle and I rotated it and created a shape. And so then we knew a whole bunch of things that were true about this very, very specific shape. What we were doing in this case is we were starting with a general parallelogram, and the definition of a parallelogram is two sets of parallel sides. So I know that it's a parallelogram, and I want to prove these two facts. I want to prove that opposite angles are equal, and I want to prove that opposite sides are equal. And in order to do that, in order to do both, I really need to get some angles in here, some triangles. So I am going to draw in an auxiliary line. So I'm just connecting what's already there with a nice little line segment. Now let's start off with our proof. When I am doing these proofs, if I haven't gotten any theorems yet, I always need to only start with my definition. So the definition of a parallelogram is the opposite, not opposite, but we have two sets of parallel sides. Specifically, I need to be more specific. AB is parallel to DC, and AD is parallel to BC. The reason that both of those are true is the definition of a parallelogram. Now, there is only one definition for each shape, so I do not need to state what that definition is. I simply just need to say definition of parallelogram. So, this is the information that I have so far. And you've proven things like this before. We want to try to get the two triangles are congruent, because if the triangles are congruent, then all of the parts are congruent to each other, just like our example up here. So How can I use parallel lines? Well, let's get our highlighter out here. These are the two that we're talking about. So that would mean these angles are equal to each other. And why would that be true? Hopefully you've answered. Parallel lines give us alternate interior angles are congruent. So that gives me these guys. But I also have another set. I have these guys. So these little dudes here would be what we're talking about. Now, I do want to be clear. You do have some options here. You can say DAC or you can say CAD as long as A is in the middle here. And then the same thing here, you can say BCA or you can say ACB as long as C is in the middle. Again, why? Hopefully you're writing it as I am. But if you have parallel lines, then you have alternate interior angles are equal to each other. So this was this little set of information. So I have both of those, and then now I need something else. So I have two angles. This side would be lovely. Hopefully you all are recognizing that. Oh, you know what I forgot to do? If we draw something else in, I need to say that we did that so we understand that it wasn't starting with that. So you just, remember, you're just communicating, saying, draw AC. And the reason is auxiliary lines. Auxiliary means in addition to, it wasn't there to begin with. So we're going to draw AC. And then I can just say that AC is equal to AC. That wasn't to begin with, but now I have that in there with our reflexive. So looking at the two triangles, hopefully you see that this side is in between these two angles. So if I have two angles and a side in between it, this is what I've got. Got my side and my angle coming into play here. And my reason would be triangle, or not my reason, but ADC is equal to where A has to go with C, D has to go with B, and then we have, what, A? So my two triangles are congruent, which is essentially now what we had up here, that the two triangles are congruent, which then means that all the parts are equal to each other. So specifically, I'm interested in my opposite angles. So I'm going to say angle D is equal to angle B. And I'm also going to say that angle DAV.
A reminder to all students that have a dog school with Ms. Williams. A dog school with Ms. Williams this week only is going to be held Tuesday and Wednesday. Tuesday and Wednesday.
So specifically, these guys are equal to each other. And also these guys here are also going to be equal to each other. So I've got my two sets of angles equal to each other. And then your final statement just needs to be whatever it is word for word. So opposite angles are equal to each other. And so I know that these angles are opposite angles. So I would use the definition of opposite for those guys there. Again, these are the angles that I wanted. Why did I choose to say those? I knew they were opposite, and so we would have definition of opposite as our reason. So that would be the red stuff there. And then, let's see, do I have another fun color? How sad. No other fun color. We'll go ahead and use pen. So then I've got this little situation here of opposite sides are equal to each other. So specifically, congruent triangles only give me congruent parts. So I say AD is equal to BC. And I also have AB is equal to DC. And again, congruent triangles give me congruent parts. So then I can say opposite sides are congruent. And the reason I can say that is these are the opposite sides. I know that because I know what the definition of opposite means. Okay? All right, we have one last one on this side. It says, what about the diagonals of a parallelogram? What do they appear to do? Well, the first thing that we need to do to have some sort of appearance is actually draw them in to find out what's happening. So let's go ahead and draw them. Now, I don't know what they appear to do for you, but this seems to be about the same length of here, and this guy here seems to be about the same length of there. So we're actually going to prove that the diagonals bisect each other. Now, we really need to figure out what triangles we want to prove are congruent to each other. First of all, do these guys look congruent to each other? They don't to me. Hopefully they don't to you. Secondly, if I prove that this triangle was equal to that triangle, I'm not going to be able to say that this section is equal to that section, or that that section is equal to that section, because these parts aren't actually a side of the triangle itself. What I'm going to need are the angles that are kind of vertical, or the triangles that are kind of vertical to each other. So I can either choose the two that are side by side, or I could choose the ones that are up and down. Doesn't matter. Either way is fine. So if you'd like to do it the other way, that would be totally appropriate. We're going to again say that we have a parallelogram. Now, here is the cool part about this chapter. Every time you prove something, you get to use that in the next theorem as well. So, right up here, I proved that the opposite angles were equal to are equal to each other, and the opposite sides were equal to each other. So looking at this two triangles here, do I have opposite angles? Again, this is an angle, and this is an angle, and this is an angle, and this is an angle. I'm hoping that you answered no, because I don't. What I do have, though, is a set of opposite sides, that this side and this side are equal to each other. Now, this is not true because of the definition. This is true because of the theorem I just proved. So I'm going to write THM to indicate that this is a theorem. And there's a lot of theorems, so I don't just get to say theorem of parallelogram. I have to be specific. There's only one definition. There's lots of theorems. The theorem that I'm using is the opposite sides are congruent. I have an angle. Hopefully you all see that. These two guys right there, we've got verticals, but you know what we need still? We need to say what we drew. So we're going to draw AC and BD, and we're going to label E. So we're going to put an E inside there. This reason is auxiliary lines. Now I can say something about the angles. So I can say angle AED is equal to angle BEC. Again, as long as E is in the middle, that's fine. No, you cannot say equals E because there's all sorts of angles that are hanging out there. We're going to have vertical angles are congruent to each other. And so far I have an angle and a side. I really need another angle. I know I'm not going to be able to get these sides because that's what I'm trying to prove anyhow. But what I can do is use the definition of a parallelogram and get that AD is parallel to BC. And think about it. If you knew that those were parallel using the definition, what else could you get? Hopefully you recognize you have some angles that you can have here. Now, we've got our parallel and our parallel. You have two options of your transversal. If I choose this transversal, I've got these angles. If I chose this transversal here, then I would have the other two angles. But let's go ahead and use those since that's what I drew. And we'll go ahead and say angle DAE equals angle BCE because of our parallel lines giving us alternate interior angles are congruent. And now we have our congruent triangles. So we have triangle AED is congruent to triangle CEB. We've got all this stuff coming in, and we have AAS. From there, I can say that AE equals EC and DE equals EB because of congruent triangles. And lastly, I can therefore say that diagonals bisect each other. And my reason is definition of bisect. All right.